Hi everyone. In this video we are going to discuss this example. We have to find residue of f of z. F of z is given there at point z is equal to 0. So z is equal to 0 is a singular point and we have to find residue of f at 0. But see, I will say this problem is totally different. Since they have added this condition, using the idea of power series division, we have to divide one power series by another power series, and using that we have to find residue. This is a different part of this example. So let me write the given function first. What we have? We have the function is cot z upon z raised to 4. So with the idea of power series division we have to find, okay. So let me clearly mention z is equal to 0 is a 101% singular point, since by putting z is equal to 0 we are getting 0 at denominator. Clearly z is equal to 0 is a singular point, okay. So after that what will I do? I will find its type of singularity as well as I will find its residue also. So f of z, let me write again, cot z. So they have asked to use power series. So that means 101% we have to find power series of that cot z. But see, really I don't know the power series of cot z. So what will I do? I will express it in a form of cos and sine, since I know power series of cos and sines. Cot means what? Cos z upon sin z. Okay, cot means what? Cos upon sine. So that's why I could express it. Now I know the series of cos and sine, so I am going to use. The series of cos z is 1 minus z square by 2 factorial plus z raised to 4 by 4 factorial plus and so on. So this is series of cos z, as well as series of sin z is 1 minus z minus z cube upon 3 factorial plus z raised to 5 upon 5 factorial and so on. In case of cos we have even powers of z, and in case of sine we have odd powers of z. Here we have alternating minus plus signs, and in this case also we have alternating minus plus signs. So let us go further. Let us use this space to solve the remaining part of this problem, okay. So what will I do? I have to divide this polynomial by this series, getting, since they have asked to use the idea of power series division. But see, to make it more simple, I will take z common from the denominator, okay. I will take z common. From each and every term you can take z common. So let me write here 1 minus z square by 2 factorial means 2 plus z raised to 4 factorial means 4 into 3 into 2 24 and so on. What did I tell you? I am taking z common from each term. So z raised to 4 into z. One z will come outside and z raised to 4 is already there. So you will get z raised to 5. Here if you take z common 1, if you take z common, z square will be there. 3 factorial means 3 into 2 into 1, it will be 6 plus, I have taken z common, so z raised to 4 power will be reduced by 1. 5 factorial, 5 into 4 into 3 into 2 into 1, so it will be 120 and so on, okay. So now what will I do? I will keep this 1 upon z raised to 5 separately. I will keep it outside and simply 1 minus z square by 2 plus z raised to 4 by 24 and so on. In denominator 1 minus z square by 6 plus z raised to 4 by 120 and so on. So simply our task is to divide this series by this series, okay, power series division. So actually this space is not enough. Make a screenshot of it, then I will go further. Okay, so what will I do? I will do the power series division on this side of board, okay. See, let me write. I am dividing this series by this one. So 1 minus z square by 2 plus z raised to 4 by 24. Okay, I have to divide this one by 1 minus z square by 6 plus z raised to 4 by 120 and so on. Here also we have infinite series, right? See, division of polynomials we have already studied in, I think, 8 or 9 standard, same thing we have to do here. First of all, we need to bring 1. So that's why I'm taking 1 here. 1 into 1, 1. We need to maintain the first term. After that, we need to multiply each term by this 1. So you will get same minus z square by 6. This one into 1 plus z raised to 4 by 120 and so on. After that, we need to do the subtraction, getting? So that means I should write minus here. Already it has plus sign. So it will be changed to minus. This minus will be changed to plus and this plus will change to minus, right? So 1 minus 1, 0 on this side, 0. If you want, you can write, otherwise no need to write. Minus z square by 2 plus z square by 6. Z square is common. We need to do the calculation of just coefficients only. So let me do minus 1 by 2 plus 1 by 6. This 1 by 6 has a plus sign. So let us maintain the denominator. I will multiply numerator and denominator by 3. So minus 3 by 6 plus 1 by 6. So minus 3 plus 1 minus 2 by 6. So it will be minus 1 by 3. So using calculator you can easily do it. So it's minus z square is always there, getting? I simply calculated the coefficient 1 by 3. I need to do it for this one also. What we have, let me do. 1 by 24, right? 1 by 24 minus 1 by 20 minus 1 by 20. I am just doing the calculation of coefficients only. Z raised to 4 will be as it is. Let us maintain that same denominator. Multiply numerator denominator by 5. So 5 upon 5 into 124, 120 minus 1 by 120. 5 minus 1, 4 by 120. Both are divisible by 4. So 1 by 30. This is the required one. So let me write minus, no, we have a plus z raised to 4 by 30. Yes, we got it, right? So the first task is done. Now z square by 3 we need to bring here. Minus z square by 3 we need to bring here. So for that I should multiply 1 by minus z square by 3. So minus z square by 3 into 1 you will get same minus z square by 3. At each and every step we need to take care of just first term only, and after that we will find the remaining terms. Okay. So minus z square by 3 into 1 you will get minus z square by 3. That means we are done. So we should have the same term and we have got it. And let us take the product of remaining terms. Minus z square by 3 into this. So minus plus, right? Minus plus. Z square into z square, z raised to 4. 3 into 6, 18. Yes, that's it. See, after that what we do, and see, many terms will be there. We are not calculating them. We are focusing on just first terms only. Few first terms. Okay. So when you write minus sign there, all sign will get changed. So this minus will be converted into plus. Plus will be converted into minus. So let us see what will happen. See this, they have opposite signs. Minus z square by 3 plus z square by 3. They will get cancelled to each other. 0, right? And see, I need to do the calculation of this. What we have, z raised to 4 common, 1 plus 1 by 30 and this minus 1 by 18, minus 1 by 18. On calculator you can easily do, but see what will I do, I will multiply numerator and denominator by 3 by 90 on, and this side I will multiply numerator and denominator by 5. So 5 by 90. Since both of them have the same denominator 90, 3 minus 5 minus 2 by 90. So 2 to cancel, minus 1 by 45. Got it. So it is minus 1 by 45 minus z raised to 4 by 45. Many terms will be there definitely. Getting? Yes. So after that we need to think about this one. We should have the same term. Okay. So and 1 is here. So we need to bring the same term here. So I will write here same minus, let me check we are right or wrong. Yes. Yes. So I should write here minus z raised to 4 by 45. So if you take the product minus z raised to 4 by 45, and many more terms will be there, but we are not worried about them. Okay, so simply we are focusing on this term. We should write minus here, then sign will be plus, and see they are having a opposite sign. So my plus minus will get cancelled and you will have 0 here. 0 plus infinitely many terms. Getting? So in this way we do the calculation, but we are interested in first few terms and we got it. Getting? Here also I should write dot 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 dot. Getting? Many terms will be there. That means if you divide this series by this series, you are getting this quotient series. Getting? There is no more space to write, just make a screenshot of it. Okay, before that what will I do? Let me remove this part. Okay, 1 upon z raised to 5. Let us use this this space first and then we'll go. I am dividing this series by this one. Finally I got, this is a quotient series. So let me write 1 minus z square by 3 minus z raised to 4 by 45 and so on. We will take the product. I will multiply each term by this 1 by z raised to 5. So 1 by z raised to 5 minus z square upon 3 z raised to 5 minus z raised to 4 upon 45 z raised to 5 and so on. 1 upon z raised to 5. Z square cancel. 3 z cube. Z raised to 4, z raised to 4 cancel. 45 z and so on. Many terms will be there. Get it? But see here, z is a denominator. You can say this is the principal part. This is what? Principal part, and this will be analytic part. So how many terms are there in the principal part? 3. So definitely z is equal to 0 is a pole. Its order will be 5. Since in denominator the highest power of z is 5. So z is equal to 0 is a pole of order 5. Okay. So let me remove this part, just make a screenshot of it, then I will go further. So let me clearly mention, therefore, z is equal to 0 is a pole of order 5. But the fact is we are not interested in its type of singularity and its if it is pole, what will be its order. We are interested in the residue. Already we have a Lorentz series expansion. So let us find residue of f of z at z is equal to 0. The definition of residue says it is nothing but b1. That means coefficient of 1 upon z minus z naught. Z naught is 0, z minus 0, z. That means we are interested in coefficient of 1 by z in Lorentz series expansion. What is coefficient of 1 by z? Minus 1 by 45. Minus 1 by 45. So this is a required answer. Okay. So with the help of power series division, we found out the Lorentz series expansion and finally we got the residue. Make a screenshot of it, then we will stop. Thank you. See you in next video.